I'm welcome. My name is Oleh Melnychuk, and I am first year PhD student at the Kiev Aviation Institute. Today I am presenting my research I conducted as part of Ukrainian NLP shared task on comparing methods for the multi-label classification of manipulation techniques in Ukrainian Telegram content. My main research keep focus on detecting misinformation directly on a user's device using AI methods. This is critical in Ukrainian context where 74% of users rely on social media for news. And AI-generated propaganda shows spread in the social media has been shown to be 37% more engaging than traditional manipulation. The UNLP shared task with its challenging Telegram dataset provided a perfect real-world use case to test how different models, especially those suitable for on-edge deployment, perform against these threats. The shared task dataset includes two classic problems. Multi-label complexity, where a single post can contain multiple manipulation techniques, and high-level imbalance across manipulation techniques. For example, loaded language has around of 2,000 samples, but strawman around of 100. So I set up two main research questions that I want to answer during the research. First, how do modern LLM-based approach like RAG, fine-tuning compare to traditional transformers for this classification task? Second one is since real-world dataset often have gaps, like our Telegram dataset, how do these models react to synthetic data designed to address class imbalance? So we choose four different methods to compare. First of all, it's our baseline with TI-ADF and logistic regression that use mode for two-class imbalance. Second one is XML Roberta Large with class weights, where we're trying to handle imbalance in this way. And also two specific LLM approach. First, it's fine-tuned JAMA 3 1 billion parameters. It is in interface tuned model, and for handling imbalance, we didn't find any better way than just do a subset of the data, created a sample of 100 example for each manipulation class. And we didn't use any classification head, so in the end we had problem with output that we tried to handle. For RAG approach, we choose a E5 large vectorizer and in-memory phase index as a fast and easy way to vector search. And in the end, generator LLM was Mistral Nemo using a API. This is structure response that help us to avoid any problem with the output. For synthetic data generation, we used a prompt-based approach and Mistral Large as a LLM for generating the dataset. We create a structured prompt that includes a description about each technique separately and three example of particular technique in Ukrainian or Russian language. So we tried to convert three examples into 50 examples. Let's go to the results. After our experiments, we got two clear outcomes. First, on the original data, the fine-tuned Roberta significantly outperformed all other methods, providing most effective at handling class imbalance. The LLM's models performed similarly to our baseline. When we are talking about synthetic data, we got a mixed result. It was sufficient to improve the back and forth like the ADF model, raising their F1 score, But for transformer, which rely on deeper semantic understanding, this data was insufficient and actually harmed their performance. So I want to highlight several critical points that we figure out in our research. First of all, it's XML Roberta is a top performer. It's a easier way to handle class imbalance with the LLMs. Synthetic data only helped of the back of words model, but for transformer, model struggled with a lack of semantic depth. The fine-tuned model, LLMs underperforms not just due to the limited data that we expected, but also do hallucination. For example, Mistral inserted French symbols, and Gemma added random symbols or rephrase labels that do a performance degradation. Our RAG implementation also confirmed a key hypothesis we wanted to validate. It's a simple semantic search is ineffective in the task because different in same topics with a similar content could be spreaded really different manipulation techniques. So also the data set contained triggered words that could have improved this, but integrating them correctly into our RAG solution was beyond the scope of the shared task. So based on it, I wanted to shape my future work, which I focused on creating a practical on-edge solution based on the research and also are my researchers. First, we plan to enhance RAG. I strongly believe in this approach, and my hypothesis is to move beyond simple text similarity. We will investigate strategies to vectorize manipulative patterns themselves, allowing us to search for the patterns, not just similar topics. Second, we will redesign our small LLM approach, not for classification, but for manipulation explanation. A task that doesn't require exact label generation. Or we will use another fine-tuning approach for Gemma 3N. It's new model that was released in last few weeks. So for overperform our XML Roberta and use it instead of it in the pipeline. Finally, it will be integrated into a proof of concept browser extension. In this pipeline, Roberta model will act as classifier, or maybe Gemma 3N if we find out a way to train it better. And RAG will retrieve relevance example to better detection, to use not only text of particular content, but also some closer content to help to extract real valuable manipulation. And in the end of the pipeline, we will have a grammar model will provide real-time hits and explanation for the detected manipulation. And all of this should be run on the edge. So it's my main goal for next few years. Thank you for attention. It's my LinkedIn and GitHub. You can connect, you can check code, and talk with me in the online.